Problem 4, a pole 80 feet tall is situated at the bottom of a hill that slopes up at an angle of 16 degrees 10 minutes. Okay, so we have the pole on the bottom of a hill, and the hill slants up at 16 degrees 10 minutes. A guy with a wire from the top of the pole to the hillside. So here is the wire. This blue side here is the hill that's going upward. A guy wire from the top of the pole to the hillside forms an angle of 20 degrees with the top of the pole. So that's going to be 20 degrees. Find the distance from the base of the pole, so the bottom of the pole, to the guy's wire's point of attachment. So basically we're trying to figure out the length of this side right there. And the hardest part about these questions is to draw the diagram correctly. Now, we want to go about using trigonometry to figure out what x is. Here is our triangle. And the problem is that this 16 degrees 10 minutes is not in the triangle. However, what we can do is this. The pole is going to be perpendicular with this bottom portion of the ground. You have the ground going this way, then all of a sudden it starts to jet up on a hill. But if you kind of extend the ground horizontal, the pole is going to be at a right angle with that horizontal. So basically this entire angle here, this entire blue angle is 90 degrees. But since they tell you this bottom portion is 16 degrees 10 minutes, I can figure out what this angle of the triangle is going to be. This angle right in here, by going 90 degrees, the entire right angle minus the 16 degrees 10 minutes. So here the angle in the red triangle turns out to be 73 degrees and 50 minutes. So now I'm going to just extract the red triangle from the diagram because it kind of gets confusing. There is my x, here's 20 degrees, here's 73 degrees 50 minutes, and here is my 80. So if you look at that triangle, let's try to figure out which of the rules we're going to be using here. Well, SOHCAHTOA means you need to have a 90-degree angle. Well, in this triangle, it doesn't look like there's a 90-degree angle. As a matter of fact, you know what two of the angles are equal to. My advice is to try to figure out what that third angle is. So what I did was I took the 7350, that angle of the triangle that we found. I added that to the 20 degrees, which was the angle up top. Then I did 180 minus that, and it turns out this other angle of the triangle is 86 degrees 10 minutes. So this is not going to be SOHCAHTOA because there's no 90-degree angle. So now I'm going to look to use the law of sines. To use the law of sines, you really need to have one matching side angle combination. And since there's no letters in the diagram, I'm going to just throw A, B, C in the diagram. I suggest you do that when you do these questions because now you can kind of set up the problems correctly. Do we have a matching side angle? And the answer is yes. Here I have now angle C that I found, the 8610, and I have side C. So here the matching set are going to be the C's. That means I'm going to be using the law of sines. So this particular question is asking me to solve for x, and x is opposite angle A, and x is a side. So I'm going to use little a over the sine of angle A, and that equals, now my matching set, little c over the sine of angle C. So now I'm going to plug into this law of sines. I have little a, which is x, over the sine of angle A, which they told you was 20 degrees. That equals little c, the side opposite angle C, or 80, over the sine of angle C, over the sine of 8610. The way we go about using the law of sines is we cross multiply. So here I'm going to have x times the sine of 8610. That equals 80 times the sine of 20. And now to solve for x, I'm going to divide both sides by the sine of 86 degrees, 10 minutes. So here x is going to be equal to 80 times the sine of 20 over the sine of 86 degrees, 10 minutes. So here our answer is going to be 27.4. Problem 5, Sarah and Zara are golfing on a beautiful summer day. The fourth hole is 345 yards due west from the tee. So here's the tee. And if you draw out north, south, east, and west, west is to the left. So here, 345 yards to the left of the tee is the fourth hole. On that hole, Sarah hit a drive to the left of the corrected position. So she hit the golf ball from the tee, and it kind of went to the left of where it should have gone. They tell you the angle of the shot is 16 degrees. Find the distance from the ball to the hole, which is located at the flag there. So basically this question is asking you to find that distance in the diagram. So here, let's go through our checklist. First, we look to use SOHCAHTOA, which means we have a 90-degree angle. In this case, no. The only angle they give you is 16 degrees, and they don't give you the other two angles, so we can't assume that one of them is 90. To use the law of sines, we're looking for a matching set of side angles. And for this particular question, there's no letters given to you in the diagram, so maybe if you throw in A, B, and C. Here, they're giving you angle B, but they're asking you to find side B, so that's not a matching set. Here they're giving you side C, but not angle C. And here is angle A, they're giving you side A, but not angle A. So there's no matching set of side angles. To use the law of cosines, there's two checklists. The first is if they give you two sides and the angle between. And the second is if they give you all three sides. And here, I think number one is going to be true. Here they're giving you, in this diagram, they're giving you two sides, side C and side B, and they're giving you the angle in between. So here we're going to be using the law of cosines. I redrew my diagram. So here they're asking you to find side B, so I'm going to use the law of cosines to find a side. If they would have given you all three sides, you'd be using the law of cosines to find an angle. So here, I'm going to use the law of cosines to find a side. B squared equals A squared plus C squared minus 2AC times the cosine of angle B. Remember, the side that you're trying to find always has to match the angle that you're using. So here we're going to have B squared equals A squared, so that's 270 squared, plus C squared, 345 squared, minus 2 times A times C, so times 270 times 345, times the cosine of angle B, which they told you was 16 degrees. The nice thing about the law of cosines is you just type in directly into your calculator that side of the triangle. Remember, when you use the law of cosines and you're finding a side, after you type in this entire right-hand side on your calculator, then you have to take the square root of that answer because it's B squared. So here our answer turns out to be 113.3. 113.3. From a certain distance, the angle of elevation to the top of the building is 17 degrees. So as soon as you see angle of elevation, angle of depression, you know you're going to have a 90-degree angle in your diagram. So I'm going to draw a right triangle. I'm going to have my building along the left-hand side. It says the top of the building, the angle of elevation is 17 degrees. At a point 50 meters closer to the building, so you're at this point, now you're going 50 meters closer to the building. So we went from the right to the left. Now the angle of elevation is 31 degrees. Find the approximate height of the building. Now what I want to do is, since I have a 90-degree angle, I want to use SOHCAHTOA to get my answer. And the building is actually in two different right triangles. It's in this smaller red right triangle, and it's in this larger green right triangle. The problem with finding the height of the building initially is that in the red triangle, you only have one angle, the 31, and you have none of the sides. You don't have the bottom, you're trying to find the left, and you don't have the hypotenuse. In the green triangle, you're a little bit closer. You have an angle. You have part of a side. From here to the end is 50. You don't have this measurement. So you can't use SOHCAHTOA initially to go about solving for x. So what are you going to do? Well, what I'm going to do is, there's a third triangle in the diagram. This third triangle is going to be this blue triangle. And what I'm going to do is this. Here's my blue triangle. What I'm going to do is I'm going to go about using this blue triangle, which I'll kind of redraw over here so it's easier to see. Here's my blue triangle. I'm going to go about finding this side right here. Maybe I'll call it y because I already have an x in the diagram. See, that side y is right here in the diagram. And why is that going to be helpful? Well, once I figure out what that side is, then I'm going to use this smaller triangle, my red triangle, to go about finding the height of the building. Because if I know now what this side is, that's what I'm trying to solve for in the blue triangle. If I can figure out what that side is, then I can use SOHCAHTOA in that smaller right triangle. Let me get back to my blue triangle. I know this angle here is 17 degrees. I know this is 50. What else do I know? Well, I know in the blue triangle this outside angle is this 31 degrees. So I know this angle right here is 31 degrees. Since I know this angle is 31, I can figure out the angle next to it because these two lie on this straight line, which makes them supplementary. All the angles on a straight line have to add up to 180 degrees. So if I take 180 degrees and minus this 31, I can figure out this angle in the blue triangle is going to be 149. So this angle here is 149. Now if I get back to my blue triangle, now what I can do is figure out what y is going to be. Here, I know this angle is 149. I know that angle is 17. So I know two of the three angles in that blue triangle. I can figure out what this top angle turns out to be by adding up the 149 and the 17, which I think is 166, and going 180 minus that, because I know all the angles of a triangle have to add up to 180 degrees. So now in this blue triangle, I want to go about finding side Y, so then that'll give me this side in my red right triangle, so I can figure out the height of the building. So what do I have going on in that blue triangle? I don't have a 90-degree angle, so it's not SOHCAHTOA, but I now have a matching set. I have the angle up top and I have the side opposite. If I throw some letters in, maybe I call it ABC, here my matching set is going to be my A's, because I have angle A and I have side A. So since I have a matching set in the blue triangle, I'm going to be using the law of sines. And what am I trying to find? I'm trying to find this side Y, which is side B. It's the side opposite angle B. So here I'm going to have little b over the sine of big B. That equals, now my matching set, my A's, little a over the sine of angle A. So here I have little b, which I called Y, over the sine of angle B, so the sine of 17. That equals little a, the side opposite angle A, 50, over the sine of angle A, the sine of 14. So here I'm going to cross multiply to solve for Y. So here I'm going to have Y times the sine of 14. That equals 50 times the sine of 17. And now to solve for Y, which is the left-hand side of the blue triangle, which is also the hypotenuse of the red triangle, to solve for Y, I'm going to divide both sides by the sine of 14. So Y is going to be equal to 50 times the sine of 17 all over the sine of 14. So here it looks like little y, the side of the blue triangle, which is also the side of the red triangle, is 60.4. Now what I'm going to do is this. 60.4 is going to be the hypotenuse of this red triangle. So that's 60.4. So now I'm going to try to answer the question. I'm going to try to find the height of the building. I'm going to use that red triangle, which is a right triangle, so I'm going to be using SOHCAHTOA. So here in the red triangle, I'm going to label my picture. I know the hypotenuse is the 60.4. I know my angle is 31 degrees. X is going to be the opposite, and the 60.4 we said was hypotenuse. So here in SOHCAHTOA, because it is a 90-degree angle, I have an opposite and I have hypotenuse, so here I'm going to be using the sine. I know the sine of an angle equals the opposite over the hypotenuse. So here I have the sine of the angle, so the sine of 31 degrees. That equals the opposite, which we said was x, over the hypotenuse, which we said was 60.4. And here we're trying to find a side, so we're going to cross multiply. Here the x is in the numerator, so I'm just going to simply cross multiply. If my x was in the denominator, then I would have to use the switcheroo rule. But here it's not, so I'm just going to cross multiply. 1 times x equals 60.4 times the sine of 31. So after doing all that work, we're going to be able to figure out the height of the building. So here the height of the building, which we called x in that diagram, is going to be 31.1. Sometimes you need to work within multiple triangles to go about getting the answer that you need.